So let us take a resistance connected in series. Okay. So when you say the resistances are connected in series, this is how it looks. So let us say this is one resistance of R1 and this is another resistance of R2 and this is another resistance of R3. So all these three resistance, that is, these are the two terminals of these resistances. So when I say these two terminals, so one end is connected to the supply, okay, that is DC supply, and the other end of this resistor is connected to one end of this resistance R2, and the other end of resistance R2 is connected to one end of this resistance R3. Now when we apply a voltage V, okay, when we say this is the supply voltage applied V across these resistances R1, R2 and R3. So when I apply this voltage, the drop across this resistance, let us say the drop means here the voltage. So let us say this is V1 and this is V2. This is V3. So the series circuit is one in which several resistors are connected one after the other as shown in this figure. So the resistance R1, R2, R3 are said to be in series with the voltage source EMF of V. So this is called EMF source. So we say this as EMF, electromotive force. Now according to the KVL, okay, what does the KVL states here? So according to KVL, the algebraic sum of the voltage across the closed loop is said to be equals to 0. So summation of V is said to be equal to 0. So what does it mean? That means V, okay, minus V1 minus V2 minus V3 is equal to 0. So in the other way, the applied voltage is equal to sum of the voltage across all the three resistances, that is R1, R2 and R3. That is, across R1 we have V1, across R2 we have V2 and across R3 we have V3. Now how to apply the Ohm's law to this series circuit to find out the equivalent resistances of this. Now how to find what is this equivalent resistance of this circuit, that is having connected in R1, R2 and R3. So if I want to apply the Ohm's law, so Ohm's law states that, as we know, V is equal to IR. So Ohm's law given is V is equal to IR. So when you make use of this Ohm's law to this equation, okay, this equation, let me call this as equation 1. So apply this Ohm's law to this equation 1. So we have V. So V is equal to IR. So I can write this is V is equal to IR. I into R will be equal to, okay, now equation 1 becomes V is equal to IR equals V1 becomes, so the current in the series, if you apply the voltage, the current flowing in the series is I. Okay, the current is same in all the three resistances. So the current flowing here is also same. So that is I. So I is same for all the three resistances. So therefore we can say here IR is equal to, now I is same, so across R1 means, let me write this as R1, okay, plus I R2 plus I R3. So taking common I on both the sides, so I get cancelled, so I into R, so equals, we can say I common, you can take R1 plus R2 plus R3. So then I get cancels here on both the sides, so R will be equal to R1 plus R2 plus R3. So the total or equivalent resistances in the series circuit will be equal to R, that is R is equal to R1 plus R2 plus R3. Now on the same grounds, let us discuss on the parallel circuit. Analysis of parallel circuit. So now parallel circuit, let us say we have a voltage here and the resistance are connected in parallel. So it is R1 connected in parallel to R2 and again R3 connected to parallel to R1 and R2. So if I say this is resistance R1 and this is resistance R2 and this is resistance R3. So the applied voltage is here V. So the current flowing here is I. So the parallel circuit, the current flowing will not be same in all the resistances. So if you look at here, at this junction, the current entering this junction, so according to KCL, the current entering the junction should be equal to current leaving the junction. So in that case, the current direction is in this way. So we can say here, let me say the current in R1 is I1, the current in R2 is I2, okay, and the current in R3 is I3. So according to KCL, I said I is equal to I1 plus I2 plus I3. So, but according to Ohm's law, what is I? I is nothing but V by R, that is the total resistance of the circuit. So we can write R equivalent, okay. So I1 can be written as the voltage in parallel. So observe here, the voltage at this point and this point is same as the voltage at this point and this point. And similarly, the voltage across R2 is also same as the supply voltage. So in parallel, voltage across all the resistance are same. So I1 can be written as, so I can write I1 can be written as V by R1 plus V by R2 plus V by R3. So if you observe, the voltage is common on left hand side and right hand side, so we can take voltage as common. So 1 by R equivalent is equal to V common, I can take this as 1 by R1 plus 1 by R2 plus 1 by R3. So as I said, here also the voltage on either sides get cancelled. So we can say V gets cancelled here. So cancel the voltage, we get this get cancels. So we get 1 by R equivalent will be equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is the analysis of a resistance when it is connected in parallel. So the main important thing you should note here, in parallel V is same. Okay, in parallel V is same. Okay, but current I is different in each resistor. I is different. Okay, I is different. Whereas in series I is same. Correct? I is same. I is same, but V is not same. So V is different in case of series. So with this concepts, so this is parallel circuit. So this concepts holds good whether it is DC or AC. When you want to find the equivalent resistors when resistance connected in series, so R will be equal to R1 plus R2 plus R3. But when the resistance is connected in parallel, so we need to take the reciprocal of it. So 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this holds good in case of AC also. That means when you replace this source by AC, okay, instead of DC, you can replace this by AC, then also the equivalent resistance will be same. Now if there are only two resistances connected, so we don't have the third resistance, so only two resistance in parallel, so we can write R equivalent, okay, 1 by R equivalent will be equal to only 1 by R1 plus 1 by R2. Now this can be written as R2 plus R1 divided by R1 into R2. So the reciprocal, if you want to take it back, so we can write R equivalent will be equal to, you take the reciprocal of it, we get R1 R2 divided by R1 plus R2. So this is the equivalent resistor when connected in parallel. That is, I am talking about two resistances connected in parallel. So in the next class we'll discuss one problem on this.